All right, I think we're good to get started. So this is the last slot of the conference. If y'all have flights to get to, check your clocks. I won't be offended if you have to leave. Get home. That's important. Fun part of going last in the conference is a lot of people have already said a lot of smart things before you. So a lot of those good ideas are already kind of out in the open. But good ideas are worth repeating, right? The repetition, the reinforcement is how we learn. So that's good. If you hear things you've already kind of heard before, then that's probably a good idea. Conversely, if you hear other interesting novel ideas here that you haven't heard before, well, they must be bad ideas, right? But bad ideas are fun too. Or if you think they are good ideas, actually, then it's perhaps your responsibility to repeat them to other people to ensure that they're good ideas. Anywho, this is Boots Made for Walking, Spring Hygiene in the Enterprise. My name is Nick McKinney. I work at JPMorgan Chase as a software engineer. I'm also a collaborator on the OpenRewrite project. I've contributed a whole bunch to Rewrite Spring, Rewrite Core, Rewrite Maven plugin, things like that. I'm not from the Spring team. There were folks from the Spring team here. If you didn't get a chance to see their talks, go check the recordings later. Real fun, real good, relevant to your interests if you're in this room here and now. But for my talk, what we're talking about here, here's a little outline of where we're going. We're doing an intro. You might say we're in that intro right now. Afterwards, going to get into some of the business case for doing upgrades. Once we start talking about those factors of the business case of doing upgrades, we're going to dig real deep into how we can reduce costs of upgrades, because that's the fun, exciting part with the tools. And woven throughout, we're going to talk a little bit about our story at JPMorgan Chase, our team's relevance, and our experience with this whole situation. So, first premise, JPMorgan Chase is really big. We have an annual tech budget of about $17 billion. We hire 44,000 software engineers and a whole bunch of other people that, presumably some of them do baking or something. And we have at least 40,000 Spring Boot repositories. The Spring Boot's not the entirety of our ecosystem, right? We use all sorts of different tech stacks, but Spring Boot's a pretty big one for us, and we've got a lot of them. Second premise is that technology goes pretty darn fast. So if we're looking at the Spring Boot ecosystem in particular, and for this slide, we're focusing specifically on Spring Boot open source support timelines and also Java long-term support versions, because if you're a big old enterprise like us, you're probably not using all the 6 months Java versions. You're probably focused on those 2-year LTS versions. All that to say, there are new Spring Boot release versions every 6 months, effectively. And there's a new Java long-term support version every 2 years, effectively. And if you start doing a whole bunch of napkin math, you could say that is about 2.5 upgrades per Spring Boot repository that you're obligated to per year. And if you also take as a given that there are 250 business days-ish per person in a work year, those are your two inputs. The next one up is the variable. If you suppose that each of those upgrades takes about a business day to accomplish, from planning to production, review, coding, all that adds up, just call it a business day. If you take those things as your inputs, then the math works out such that 100 repositories, it takes enough time to fill a person's entire work year just doing those upgrades. Or in the context of JPMorgan Chase, if we've got 40,000 some Spring Boot repositories, you could argue that it takes that there's 400 people worth of capacity spent just doing those upgrades year over year. And that is a big old number. We have an intuitive understanding of upgrades being good, but that's a pretty big number. It's probably not allocated like that. You're not organizing your organization to have 400 people dedicated to doing this. It's spread across a whole bunch of developers, but that's capacity that you could be reclaiming and dedicating to more interesting feature development if you can make upgrades cheaper. But again, that's pretty darn expensive. Well, we just don't upgrade at all, right? Like, how do we make sense of this scenario and justify it? So I did not go to business school, but I feel like you could express that sort of justification in a little bit of pseudo-math like this. You could say the business value of doing something is roughly equal to the amount of the thing that you're doing times the difference of the benefit of doing it minus the cost of doing that. So if we want to figure out some sort of business case for upgrading, the questions then are, what is your scale? How many things do you have in your organization? What are the benefits, in particular, that you expect to reap? And then how can we reduce the costs? What is the cost and how can we reduce that to make it very cheap to do so you get full benefits with very little cost? So this is going to be a theme. We're going to see slides pivoting around this going forward. But first, we're going to do a little bit more contextualizing from our story, because the problem I'm describing here is essentially our problem at JPMorgan Chase. My team owns a thing that we were going to call here generically JPMC Boot. JPMC Boot is our lightweight wrapper over Spring Boot. So The main mission of JPMC Boot is to enable effective usage of Spring Boot and Spring Cloud within JPMC. We're not trying to add a million features and opinions. We're trying to add just enough to make it practical and tuned for the JPMC environment. And there's about 10 of us. There's some diagrams on the bottom here that try to contextualize the scope of JPMC Boot. So on the bottom left, there's a diagram showing just feature scope. At the bottom of the diagram, there's the huge planetary off the diagram feature set that is Spring Boot itself. JPMC Boot is a little wrapper on top of that that has some key features. And then to just really convey the complexity of our ecosystem, there is also yet another prominent framework within JPMorgan Chase, we'll call it Chase Boot here, that is built on top of our thing, JPMC Boot. So we are both the builder on top of and the one being built on top of at very high scale. And that Chase Boot, serves a more specific business and more specific architecture goals, as a whole bunch of features. And if you look at the right, you see some usage numbers. And I've put these usage numbers in terms of 2022 and 2025. We're going to hear more about 2022 later because that's a fun moment in our journey. But these are where some of the numbers that I mentioned at the top come from. So if we focus on the 2025 numbers, there are 5,000 raw Spring Boot repositories in JPMorgan Chase, 26,000 JPMC Boot, and then another 9,000 that are using Chase Boot. And again, those frameworks build on top of each other. So you'll see JPMC Boot, thing we support, is taking the largest share. All the things that are Chase Boot in theory are also reliant on JPMC Boot to some extent. And due to our just market share, you could say, in JPMorgan Chase, we also are effectively this locus of expertise for raw Spring Boot as well. People with those kinds of confusions end up coming to us, and we help them to the extent that we can, often encouraging them to hop over to our JPMC Boot to reap the various little benefits that we recognize. So our team, again, is supporting those 40,000 some repositories supported by quite a lot of engineers with diverse goals. And again, there's like 10 of us tops. So we are working at a very, very, very high scale, very leveraged in terms of people doing the work versus people supporting. So we are very invested to make sure we can do this thing cheaply and effectively and predictably. All right, so let's get back into our little business case. So the first thing I'm going to talk about is inventory. So when you Google quotes about measurement, as you do when you're preparing slides, you get a lot of Lord Kelvin, the guy who named the units of temperature. This dude just loved measuring. He's got a lot of quotes about it. I think he'd probably be pleased with his legacy as being known mostly for being a unit of measurement himself. But all these things to say, measuring is really important, and the science guy agrees, right? If you're trying to demonstrate movement or progress, or that you have a problem in the first place, if you cannot quantify it, you can't really show that you have a problem, and you also can't show progress against it. So we're going to talk about a lot of things, and this discussion on inventory is brief, but it is really fundamental to everything else you might want to do to try to really show progress in this ecosystem. So if you don't have your inventory, like I showed you a whole bunch of cool numbers about how many repositories we have on the previous slide, there's more numbers to come. I've got numbers like that for JPMC. If you don't have numbers like that for your organization, I suggest you invest in that. And some places you might want to start by looking at might be your scanning tools. You probably have scanning tools. You probably have tools that are checking if all of the different open source dependencies that your project depends on have vulnerabilities. And those scanning tools probably then know the full set of dependencies that your project's using, which means they kind of know who's using something like Spring Boot. So if you can kind of weasel your way into that data, that can be the beginning of an inventory. Beyond that, an SBOM repository is the new shiny hip way to do something like this, to make that sort of knowledge about what dependencies are used by a project, like a first class data element. If you have an SBOM repository, then you're already sorted. You're in great shape. OpenRewrite and Modern can help with things like that. You've probably heard about that. It is day 2, is the final time slot of the conference. If you haven't heard about Modern and OpenRewrite, sorry, oops, I don't know where you've been. I can't really explain much more beyond that. SBOMs and search recipes, OpenRewrite can help with. When I say search recipes here, I'm saying, suppose getting a whole SBOM for all of your software projects is just a large endeavor. You could start with something similar if you've got an OpenRewrite Modern ecosystem by just defining recipes that specifically look, hey, does it look like this project is using Spring Boot? And go gather version numbers and usage numbers that way and start very tactically and build out an inventory with that beginning. All right, so let's talk more about benefits. So I also didn't go to art school, but I think when we talk about benefits, it's often in terms of carrot and stick, in terms of when we're talking about incentives, and I think you can kind of represent them visually this way. really enforce the memory. So in the ahead of you are the carrots, the cool, nice things you can gain by doing something. Behind you is the stick, the sad thing that happens if you aren't able to make progress. And then in the middle are your boots, stuck in the middle, being compelled by these forces. So we're going to look forward at the future, the nice stuff first. Let's talk about carrots. So positive incentives for upgrades include things like features. So if you are a Spring Boot application and you want to use Spring AI to talk to AI stuff, Spring AI is coming out in a couple days, GA, and that's not really coming to Spring Boot 2.1. It's coming to things like Spring Boot 3.5-ish that are out now. So if your project is still on Spring Boot 2.0 and you want to use AI, it's not there. You're going to have to do some work. Also performance, you see this particularly in the JDK itself, a little bit less so in Spring Boot, but these things tend to get better and faster over time. So by simply upgrading, you can tend to get free runtime benefits in your estate by using the shinier versions of these foundational tools. On the right-hand side of that little box, we've got bug fixes and security fixes. Those are intuitive, important, but intuitive. One thing that I think is a little bit more subtle is supportability. So when you are a framework provider like us, you are used to maintaining multiple versions of your framework and therefore answering multiple questions about multiple versions of your framework. But I don't want to understate that that is difficult, right? So if you are more of a software, if you are like a business application developer, to help internalize that, like imagine you receive a call about your business application and someone says, hey, I am a time traveler. I am in 2022 and I just pressed this button in your app and I thought it would do this thing over here, but it actually did this other thing. That would be a really confusing experience. You have to go back and remember how the application behaved 3 years ago. And even if you can identify, oh, this time traveler has found a legitimate bug, you're not going to fix it in 2022. You're going to fix it in 2025. So if you are someone who relies on something like Spring Boot, and you have any sort of support needs, your needs will be much more easily met if you are with that cohort that is near the present, near the future of where versions are. And you'll have a harder time getting support if you are years and years old. But you might say, these things don't really interest me. You might say, my application has not been touched for 10 years. It is a spinner that tells us where we're going to lunch. It doesn't really matter if this thing has problems. I don't care about it. In that case, you might think about the other side of this, which is the stick, the negative incentives. And in a large enterprise, that stick might look like spooky emails. It might be you getting emails from strangers telling you that you must, with ambiguous reasons, do whatever they want you to do. Otherwise, they'll continue making noise in your organization. Our team and our organization tries to do better than that. We try to not use that strategy. The real stick, I think, is risk management. So the premise here is that you might not need anything from the newer versions of software today, but you probably will eventually. And I think the most visible example of that is when something like a zero-day vulnerability pops up and something like a log4shell happens. You will be suddenly very strongly reliant on something that exists in newer versions. And if you are a far distance away from those newer versions, you're going to have a very sad week or month upkeeping your application to get to the point where you have patched out the very scary vulnerability. The diagram in the bottom left kind of describes that a little bit impressionistically. You can tell I worked very hard on that diagram. If you are very far away in distance from the version of the version which contains what you need, the amount of effort to get to that version to complete those upgrades compounds over time. You are doing the simplest, cheapest upgrades by staying near the front and doing small hops. As soon as you're trying to do larger hops over a compressed period of time, effort compounds, it gets difficult. Another example of I'm attempting to predict the future of scary risk fire drills, post-quantum cryptography. We are pretty imminently approaching a world where there's a realistic threat that the TLS protocols, the TLS ciphers we've relied on for years and years and years for network traffic are simply not safe anymore against the most sophisticated attackers. So there might be a time in your organization in the near future where your organization says, hey, we cannot be using these old protocols to communicate anymore. We need to be using new ciphers. And if you need those new ciphers for a Spring Boot application, those ciphers are probably going to be coming with a Java upgrade. And the Java version that contains those new ciphers is probably not going to be Java 6. It's probably going to be more like Java 25, which is coming out in September, or maybe 21. They might backport it. We'll see. But if you're on Java 6, you're not going to get the new ciphers, almost certainly. So if you have a Java estate and you are far behind, this is something that might come to a risk organization near you in coming quarters. And being able to anticipate that spooky thing will help you. To continue the boots metaphor, right? If you're on these older versions, your boots are on unsteady ground, right? The ice is cracking beneath you, and it might be fine, might continue to be fine for a while, but also might start to crack and you might start to slip in. And if you are starting to slip, that problem is not solved with a heroic sprint. You will probably break more things along the way. It's solved by slow, steady, measured progress. It is solved, if you will, by walking continuously out of the cracked ice. That said, I'm pretty sure if you are on ice like that, you're supposed to like get way down, like on your stomach and crawl to like spread out the way. I didn't go to wilderness survival school. Don't listen to me too closely on this. Also, just don't step on big ice lakes in the first place. That would be my primary advice for risk management. Okay, so we're going to start pivoting a little bit more towards the cost of doing upgrades. And along the way, we were going to talk a little bit about the amount of upgrades that you're doing, and that involves describing the versioning model of Spring Boot. And I'm going to sip some water before we get into that. All right. Spring Boot uses semantic versioning, which everyone should know and love. So that's typically a three-part version scheme, major, minor, patch. The most recent, hopefully still most recent, I might have made these slides last month. Most recent version of Spring Boot, non-milestone, is 3.4.5. So that's major version 3, minor 4, patch version 5. And the Spring Boot ecosystem, the release model, I say, mostly pivots around the minor version. So minor versions, when I mentioned Spring Boot's released every 6 months, minor versions are what I'm talking about. Minor versions are released every 6 months. They're supported for at least 12 months, again, in the open source support model. Spring commercial support exists, but JPMC, we do most of our planning around the open source support model. And minor versions can contain breaking changes. So little tweaks you need to do to make your application behave as it did before. If we kind of expand our orbit a little bit, a major version, I think you can effectively think of as a jumbo minor version, right? They're released infrequently. They're supported for 3 years or so, as long as you are on a supported minor version within that major version, and they can contain more and more dramatic breaking changes. So for example, in Spring Boot 3.0, we had the increase of a baseline Java version from 8 past 11 into 17. So the hop of several Java versions. That is more work than usual. That can be disruptive. Spring Boot 4.0 is expected later this year. It's roughly the next one coming up. I have not checked recently, and I haven't asked the Spring folks over here earlier if that's expected to include Java baseline versions, because there will be shiny new Java versions available. But for one reason or another, Spring Boot 4.0 is coming. It'll probably contain some jumbo breaking changes, so your applications being prepared to absorb that later this year is in your best interest. And then the other side of this, patch versions are released every month for supported minor versions. And I think you can think of these mostly as the engine of that support. So when we say a minor version is supported for at least 12 months, that's to say that there will be a patch version every month for those 12 months that, in theory, has no, air quotes, breaking changes, easy for you to pick up, and will fix little vulnerabilities and versions like that. When I say no breaking changes, that's not it has not never happened, right? If there's a very important vulnerability that must be fixed with a tiny breaking changes, sometimes that's worth it. Spring Team has room to make good choices, but for the most part, as a developer, you can plan around a patch version, almost certainly always being safe and seamless to pick up in your application. All right, so this is the timeline. Let's visualize that timeline a little bit further. So this is that Spring minor version open source support lifecycle visualized. So we have sketched out several years generically of these minor version releases. So they're releasing every 6 months, supported for at least 12 months, and you can see that leads to this kind of like staggered step function of version support. And the question then is, if I've got an application, when am I actually going to do my upgrades? Like, let's be very specific about, like, when am I planning to do upgrades on my application? Excuse me. The frequency of your upgrades, as reminded by the chart at the bottom, affects the scope of work in those upgrades, but there's a few other factors as well. So the most intuitive upgrade pattern would be simply upgrading every 6 months. You are going to touch every single minor version as it becomes available, hop over. This requires the most discipline, or requires the most frequent planning and prioritization among your team, and it carries the least risk because you are always on a supported version. This is the simplest pattern, but this might not fully meet the needs of all applications. Another example, let's say we stretch a little bit more and say, I'm going to upgrade every year or so. At this point, you are mostly on supported versions. There's going to be a few weeks, months, depending on your timeline, where you're not on a supported version. And if so, that's that, there's a little chance you might have a rough weekend there. Something spooky comes out in that window of time where you're not on support version, but mostly you are. And now you're on a yearly schedule. And you can see how you can kind of extrapolate from here and see how this turns into more and more options. A more bare bones model could be saying we're going to upgrade our stuff once every 2 years. I'm going to lump it up. I'm going to lump the Spring Boot releases with the Java long-term support releases, do it all in one swing. My risk tolerance is fairly high. I'm going to be on unsupported versions for a while, but maybe my application is not all that critical, and maybe that's okay. Maybe that's easier for my team. And the final example would be basically not having a plan, not upgrading at all by default, and waiting until the spooky thing arrives, and then embracing that awful week and month to fix everything and shoot up to the supported version in response to what you need. This is essentially gambling, right? This is taking a bet to say, like, I don't care about my application that much. This is the team lunch spinner, right? If this goes wrong, we're not going to be in too much pain, and maybe it's worth it to take the bet of never actually having to upgrade. That could work for some apps and some organizations, but if you are, say, a JPMorgan Chase that moves the majority of the U.S. financial system on a daily basis. I'm not the banker. We move a lot of money. We don't really want JPMorgan Chase to go down. In that case, if you have a tighter risk tolerance, you're probably in one of the higher buckets where you want to have your application inventory staying on support versions, upgrading more frequently. And again, by doing that, by upgrading more frequently, you keep your efforts overall down. It's a relationship between the effort you're willing to spend and the frequency and discipline and prioritization that you can get in across your team. So from there, let's talk more directly about how we can reduce costs of upgrades. So there's a few options here. And this is from the perspective of you being a central team, like a JPMC boot team, or even just a team at your organization that happens to have some responsibility for people's Spring Boot usage. So what are things you can do to help your broader community stay up to date? The first example is just kind of telling them, right? I think a lot of developers using Spring Boot don't even necessarily know the support model that I just described previously, and that is important to their planning. So simply telling the community when it's time to upgrade is helpful. And you can tailor that, right? So on the right-hand side of the screen, I've given sort of a mocked up conversation that you can have with your users to say, what is your risk tolerance? How often are you trying to upgrade? What are your goals as an application? And once you know what their expectations are, I want to upgrade once a year or so. I don't want to be more than n-1 and -2. You can help give a tailored monitoring and communication train for them to let them know, hey, the release you want to pick up has arrived, or it's been a few weeks, you still haven't upgraded, you're missing your target. By getting that buy-in from the users, you're probably doing a little bit of a psychological trick to help get the benefit, right? It's like if you're talking to a toddler and you say, hey, do you want to brush your teeth right now or in 10 minutes? And both of those options are fine for you. They're still going to brush their teeth, but they keep a little bit of autonomy and they are more invested in the outcome, in the commitment that they've made. Next thing, documentation. If you are in a large organization, perhaps many of your users are maybe not as used to going out to the internet to read documentation for things that they're using. Maybe they expect everything to be internal and confusing. So just reminding folks where the Spring Boot documentation is, pointing it to them. If you do have any internal complexity, make that clear in documentation and point out to the Spring Boot public complexity and documentation wherever possible. Another thing you can do to reduce cost of upgrades is support humans that can help other people do this work. And this really comes down to how much you are able to offer. So do you and your team as Spring Boot guides perhaps in your organization, do you have a population of people on your team that have a lot of Spring Boot expertise and are able to sit with people from across the enterprise and answer questions for them? This is hard to scale. It's important for the most complicated cases, but it's hard to scale. This usually isn't the brunt of your support. One thing that does scale well, though, is open source community, right? So for one thing you can do here, when you have those conversations with users and you are talking to the users of Spring Boot who have like the most precise understanding of what's going on and the issues they're seeing and what they want to make happen, it is valuable to just redirect those people into the open source community, right? Any channels you can get to get more people into open source helps grow open source. Growing open source helps all the people that benefit from open source. It's wonderful. So wherever possible, again, in big enterprises, you might have governance processes around how contributing to open source works, but it's worth doing. So giving people those nudges wherever possible is valuable. And the last thing on the slide, the thing that developers like is tools, right? Like what kind of technology can we use to reduce costs? This, spoilers, is about to be OpenRewrite. It's an OpenRewrite kind of conference. But let's start digging into that more now. So let's talk about JPMC's experience with OpenRewrite. And that brings us back to 2022. So in 2022, we're not using OpenRewrite. OpenRewrite's quite new, right? But what we do have is a lot of JPMC boot usage. So we've got 28,000 some boot repositories, Spring Boot, JPMC Boot, Chase Boot, 28,000 or so, and we're up to 70% of those repositories being on supported versions. And we got there through really hard work, through a lot of the processes and documentation strategies and support strategies that we described on the previous slides. One thing I hadn't mentioned, we also had our own basically flavor of Spring Initializer, right? Where we can generate someone on our JPMC boot blueprint and have our applications know that they're starting in a known good place, and plug in their own little starters and have a good starting point to move forward. That feels pretty good. We have grown a whole lot. We are pretty well supported. 70% is our organizational target. That's where we want to be. But scary things are coming, right? Spring Boot 3.0 in 2022 is coming pretty soon. And as I described before, that includes big Java versions, that include big Java version changes, that includes Spring Boot changes. We also need to throw in some changes of our own, right? We have been around for a few years, several years now as a library, and some of the things we've built kind of need a more heavy-handed refactor than what they were when we first drafted them. And we also don't really have a great sense for how our users are doing in terms of code quality, right? We don't have a ton of visibility at scale into how our users are using the JPMC boot ecosystem, except for the ones that come talk to us. So we see these large changes in the future. We see these high hurdles coming, and we don't really know how the boot applications are doing, right? We have a fear that the boots are muddy at this point, and we've got big hurdles coming, big scary changes, and we're concerned that if we can't get more help to the users to do these upgrades, our supported version number might just fall off a cliff, right? We might have a lot of repos simply don't take the efforts to do the big scary jumbo upgrade, and they might just not recover, right? We don't like that. So the experiment there, timing worked out such that we had heard about OpenRewrite, and the experiment was, is OpenRewrite any good for this? And again, spoilers, the answer is going to be yes, but let's talk a little bit about why. So the things we were looking at when we started evaluating OpenRewrite, so general benefits we're observing, right? The barrier for entry using OpenRewrite is a whole lot lower than reading docs and understanding them and applying them. So if you're imagining reading through the several page scrolls worth of Spring Boot migration guide, plus our little bit of extra JPMC boot migration guide for the features we added, that's a lot of features. The average application probably isn't using all of them, right? So it takes a good chunk of work as a developer just to read and comprehend what you might need to do, then apply it to your application, and then faithfully make those changes and get a working application. But what developers are really eager to do is just kind of like run a command, right? So if you can take the OpenRewrite recipe and have a command line replacement that just gets started the upgrade, that's so much easier to get upticks compared to having someone have to read a whole bunch. We also get more consistent results. These OpenRewrite recipes are deterministic, which is so valuable in this kind of thing. They behave roughly the same. They behave the same way given the same inputs. So with the same migration will be performed roughly the same way for every application in our ecosystem. These recipes also have historical upkeep. So if we look at the diagram on the right, this is a very limited, y'all have probably seen some of like the big like cluster visualizations from Modern about how big these recipes can get. This is a very streamlined representation of the Spring Boot recipe ecosystem. Excuse me. So the Spring Boot 3.1 recipe, for example, calls a Spring Boot 3.0 recipe, which calls 2.7 and 2.6 all the way back to 1.5-ish, I think. Along the way, the Spring Boot 3.0 recipe includes the recipe to get you to Java 17, which includes Java 11, which also includes Java 8 if you missed anything. And also, if you follow another branch here, the Spring Boot 2.4 recipe includes JUnit 5. Spring Boot 2.4 kind of was trying to push people away from JUnit 4. At that version, but a lot of people kind of kept using it because JUnit 4 upgrade to JUnit 5 is pretty tedious manually. With the recipes, you have all of these changes being called consistently historically on these repos. So if you have a repository that is ostensibly on Spring Boot 3.1 and now it's moving to 3.2, but it's also still using JUnit 4 because technically these things are still compatible, it's just a little extra cruft, the recipe can go back and identify that and help smooth out that part of the migration that was neglected previously and get you to a more complete, more holistic version of Spring Boot 3.1 or 3.2 compared to if you are just focused on the current changes. If you're just focused on the current and future, you're reading the Spring Boot 3.2 migration guide, you're never going back and reading the Spring Boot 2.4 migration guide, and you're never going back and remembering to do the JUnit 4.05 upgrade at scale. Individuals will, but at scale, Users probably won't, if we're being a little bit pessimistic. Beyond that, how it's for us in our ecosystem is that this also gives us more of a point of control, more of like a little tendril back into our users' applications to do little bits of code upkeep. We had our known good starting point with our own flavor of Spring Initializer, but once the application has been developed upon for several years, we don't really know anymore what's going on in there. And most of it, business logic, sure, we don't need to know about that. But if you're using the Spring Meta boot, Spring JPMC boot features to an extent, we have some stake in understanding how we are using them and helping with the upkeep. So with OpenRewrite recipes, we can now plug in a little bit and make those changes. And also, this diagram shows how you can compose a whole bunch of things together. It's easy to compose recipes into bigger recipes. So if we start writing our own JPMC boot recipes to handle JPMC boot specific concerns, we can kind of plug in that with those new features with all the existing Spring Boot recipes and have a great big holistic useful bit of technology. So process aside, if we go to results, we got some graphs here. Our usage of OpenRewrite effectively launched in 2023, or at the very tail end of 2022, but nothing really happened in December, so that doesn't really count. Usage of OpenRewrite in terms of unique users grew quickly and steadily for months with next to no advertisement. We essentially just started putting in our JPMC boot migration guides, hey, this OpenRewrite is the way to do the upgrade, and that was about all it took. And pretty quickly, on the order of months, we would hear people that are not us recommending OpenRewrite to each other because the tool simply does work that well and is helpful. In terms of the supported versions story that I was telling before, so as I mentioned, in 2022, we were at our 70% supported versions metric, and we were really happy about that. That took hard work to do. At that point, we roughly started introducing OpenRewrite recipes, and with the introduction of those OpenRewrite recipes, our support version numbers crawled even further to like levels of height that we hadn't seen before, up to 85% before we eventually 3.0 went end of life. And 3.0 going end of life, again, comes a little while after 3.0 gets introduced. So this, for our purposes, hit in late 2024. Late 2024, 3.0 goes end of life, and our support version count drops from 85% down to 53. And that does hurt. 53% is below our target, but like half of our supported repos are no longer supported. That feels bad. But what is important to see here is that the number started crawling back up. That drop to the end of life of 3.0, help gave the reminder that people needed that, hey, it's time to do another upgrade, right? You are unsupported in this case. And the numbers recovered. And what that brought us to is that as of now, we're at roughly 67%, which doesn't sound that impressive. That is 3% lower than we started. But no change is not the baseline that we were planning against. We were fearing that if we did not provide better tools for our users to handle these upgrades, that when the 3.0 cliff occurs, when the versions before 3.0 go end of life, we were concerned that our support version numbers would go down far and stay down and not recover, because we expected many users would simply not choose to do that extra work to keep on the train. But instead, that's not what happened. We reached that end of life cliff, and we stumbled a little bit. We hit the mud. We stumbled. We recovered. We kept walking. We remained consistent. Again, this is not huge dramatic spikes, well, except for the part where I'm down. This is not huge dramatic spikes in heroism. This is gradual, consistent recovery, measured pace, walking. That said, in terms of the stats we got today, so again, JPMorgan Chase has 44,000-ish software engineers. We have about 16,500 unique users of OpenRewrite in JPMorgan Chase. So basically, over a third of our software engineer community has used OpenRewrite voluntarily for things like this. The Spring Boot ecosystem is a large part of where we get our usage. We also have a good handful of recipes that help with things like Terraform upgrades. We also have some recipes that help with configuring our own internal CI/CD tools at the repository level. But the Spring Boot ecosystem is a large part of this, and that set is growing, right? We are a federated contribution model. We accept contributions from other internal technology products to produce recipes to help their users with those particular products' migrations. So if this sounds great, and if you are someone who maintains tech for tech software internally, if you are a software producer with software consumers in your organization, you might be bought in, and you might say, where am I going to start? If I have all these versions, which version should I start writing the recipes for? If you've got a version range like this, your version usage is probably roughly kind of a normal curve, if I'm guessing. Most of your users are probably like a little bit behind, and then there's probably a tail of users that are at the very latest, and a long tail of users that are pretty far behind. Your instinct, just to be methodical, might be I'm going to start writing my tooling from one end or the other. I'm either going to start with the very latest and work backwards, or start at the very end and start work forwards into the future. That is sensible, but probably does not yield the best results. You're probably getting the better results by starting somewhere in the middle. The reasons are twofold. One obvious reason is that the middle is where most of your users are, right? So pretty overtly, you deliver tools that help more users if you send the tools where the users are. But also, if you think about the personas of the people that are in either of those parts of this graph, the people who are already on the latest versions of your framework seem to be doing kind of fine with their upgrades already. They already seem to be motivated to be on the latest versions and are getting by fine without your tooling. Tooling will accelerate them, but they're already doing it. They're already committing to it. So you're not going to see much of a change in your supported version lift by targeting that end. At the other end, someone who is on a version of your software that was written 7 years ago has probably already given up. That is probably the team lunch spinner. They probably new tooling to make the upgrade faster is probably not going to be the thing that convinces them to do the upgrade. They're probably fundamentally not interested in doing it. And to an extent, if that matches their risk tolerance, that is a thing to accept. So for those kind of circularly compounding reasons, if you want to start with these migrations, starting kind of in the middle is probably where you want to go. Again, continuing on that theme where you are a software producer trying to reduce costs for your users, if you are releasing new versions, you should probably be having migration guides for your users. And here's an example of what that might look like. This is a kind of a mock-up of what a lot of our migration guides look like. And the thing to highlight here is that these migration guides are useful before, during, and after you have recipes. Before you have recipes, these migration guides are necessary, right? These are essentially the only way your users will know how to adopt newer versions of your software. While you are writing recipes, when you're in the middle of that journey, these migration guides serve as a useful scope for your own purposes of all the things you need to get done to make your recipe exhaustive. And then after you have recipes, these migration guides remain useful. One is a clarification documentation of which things the recipe is expected to do and to not do. And also, if anything goes funny with the recipe, the migration guide remains a useful secondary reference point for how a user can manually recover and finish a migration that a recipe has started for them. On that last point of a user kind of finishing a migration that a recipe has started, expectation management can be tricky. So OpenRewrite can be used to do simple things, right? Change 1 or 2 lines in a JSON file, easy. OpenRewrite can also be used to do very, very big and complicated things, right? Like imagine that big Spring Boot graph, or if you've seen some of the modern visualizations of like how many nested recipes are in a big old recipe, that is insanely huge. And also the problem surface is also very, very huge. Spring Boot has so many features, and there's so many ways the client code can be using it. There is enormous variability in the problem space and in the scope of the solution. It is inevitable that not everything is going to be covered for a particularly complicated problem and recipe. So the best way we have come up with to kind of convey that to our users is with this kind of mantra that I've put in a scroll here in the slides. So a developer using complex OpenRewrite recipes should, 1, expect to complete common migration tasks faster, 2, be prepared to supplement the results with manual changes, and 3, plan to perform regression testing on the application prior to release as if the upgrades were performed manually. Please test, still test. Nothing will make you not need to test. On that note, relatedly, when we tell people that they're imminently trying to go from Spring Boot 3.0 to 3.1, the workflow we recommend is to first start with the Spring Boot 3.0 recipe. Run it again. Because there's that big historical list of scope, there's a fair chance that there will be some, and because these recipes keep evolving, there's a fair chance that even the recipe for the version you're already using might make some tweaks to your application that'll make it a newer, shiny, more idiomatic version of a Spring Boot 3.0, for example, application. And getting those changes in first, verifying them, committing them, isolating them, makes it easier when you then move to the next version, run the Spring Boot 3.1 recipe, and watch it add in all sorts of new changes. Any step you can make to kind of isolate those changes will make your overall life easier, both in terms of clean git diff commits, but also if anything goes wrong, your life is easier if you've taken smaller steps, which is also to say we consider it a large anti-pattern if you're on, say, Spring Boot 2.5 and you want to go to Spring Boot 3.4. We tell people please do not just immediately run the Spring Boot 3.4 recipe. The recipe will try. It'll do its best. It will not stop you. But if anything isn't covered in that migration, and you now have years and years of docs that explain what happened in those versions, you're going to spend so much time troubleshooting where exactly the problem was introduced in the first place before you can work on resolution. It can feel slower, but the results tend to be better in the long run if you take these small steps. Again, walking, not leaping and bounding. At this point, you might also say, running these recipes is cool. Also sounds kind of tedious. What if I just run these recipes on all the repos that I care about and just ship out the PRs and do everything for them? We've heard a little bit about this in previous conversations. This is my take on it. So when you think about recipe bulk execution, the question is, should I just run this recipe in bulk for everyone, send them the changes, open a bunch of pull requests? This diagram is kind of written as like a deterministic flowchart, but you should read it more as like a teen Vogue quiz, right? Where you want to answer all of these questions and then kind of assess, how many times did I say yes? How many times did I say no? How close am I to which conclusion? So the questions included in this chart are: one, are the changes simple? Are you just trying to change like 2 lines of JSON, or are you trying to change dozens and dozens of features in a giant framework? Are the changes simple? 2, is the recipe exhaustive? If you have a large set of changes, is the recipe actually going to cover them? Have you made sure that the recipe is pretty robust against different ways that that semantic goal can be achieved logically and syntactically in the code? Third, will random PRs be received with grace by the developers you're sending them to? Things I've been hearing in this conference is that often no. It's kind of a rare culture where that works well. But you might be in that culture. If so, excellent. And then fourth, do developers trust their tests? I think many developers kind of don't trust their tests. I think a lot of unit tests in the industry are kind of bad and kind of not that valuable. And I think a lot of developers kind of know that in their bones, but the path forward isn't really clear. I'm also hearing, it all comes back to tests frequently throughout the talk. So I'm gonna plug a book later, but like unit testing is valuable, important. There's room for investment there, and that is again a foundational piece of being able to do rapid migrations like this. So the final conclusions of this graph: if you answered yes to all these things and it's a trivial change and you think it's going to go great, sure, try it, right? Even if you get a very low success rate on people merging those pull requests, if you get like 10-20% success rate, it's still 10-20% more than you had before, right? So if you can do these things cheaply and if you can get some merges, that's pretty good. Something like a Spring Boot upgrade, in our experience, works best when there is a developer sitting at the desk, initiating it, bought in mentally, and prepared to have that conversation with the recipe and its diffs and the execution of their application to figure out exactly how to get it 100% of the way there. So the alternative path here is not a hard no, it's a maybe not yet, right? These 4 questions are things that in theory the levers you could turn over time in your problem space and in your culture. And maybe if you can turn a few more of these levers further, then there's an opportunity to evolve towards doing more ambitious things via bulk execution, but it might not be the place you want to start for the most complicated cases. All right, this is one of the last slides. It's also kind of my favorite, and this is also, you can tell where I got like the wildest in Excalibur. So this is the new deal, I would say, between a tech-for-tech software producer and a software consumer. In the before world, these upgrades, this work that was inflicted by the software producers on the consumers in order to take on newer versions, was distributed like this. So the software producers would take their knowledge, they would imprint them into migration guides. Software consumers would read those migration guides and then try to update their applications. And the implication of the arrow style here is that knowledge tends to degrade at every step of the process, just because learning is hard and there's a lot of it. And many developers don't feel incentivized to perfectly learn every detail of the Spring Boot 2.6 migration, almost like they got other stuff to worry about. If you then kind of represent where the effort is coming from in the right, you can see that the software producers are taking on a good chunk of complexity, designing the changes, understanding them, writing them down, putting them in a guide in the way that is understandable. And that takes work too. They're putting in a good little chunk of effort in the little blue bar. And then the software consumers are also taking on a good chunk of complexity, maybe a bit less, because they probably don't need to worry about every single step of the migration. If it's a large framework with a lot of different features in it, maybe they're not using all of them. But the consumers are doing a lot of work to actually comprehend and apply those upgrades. They're doing perhaps all of the work of the upgrade because they're the only ones touching their code bases. Where we can get with things like OpenRewrite and automated migrations is in the below. So with things like OpenRewrite and recipes, software producers still produce migration guides, still useful, but they can also produce these recipes. They can encode the knowledge into automation. And then the software consumers can still read the migration guide, but they can also go and click a recipe which can consistently deterministically apply the changes that the producers have designed. And at that point, the migration guide, I think I mentioned this before, is more of a secondary reference material for the software consumers when the recipe does not cover everything completely perfectly. So the software consumers' primary responsibilities are to run the recipe and to validate the application. And then the kind of chart of effort, division of responsibilities, is changed as such on the right. So the complexity on the software producers does go up, right? You're doing recipe development now. That's more work than you're doing before. That's more complication than you had before. That's harder, right? So your work also goes up a little bit as a software producer. Software consumers are dealing with much less complexity because for the most thorough recipes, they don't really deal with much complexity at all, right? They run a recipe, they put forth zero thoughts about the migration, and they verify that their app still works. They're also doing, again, strictly less work because on the right side of that chart, the robot is now doing a lot of work. Automation, OpenRewrite recipes are doing the work of that upgrade. And if you kind of compare the top and bottom charts there, you see a lot of arrows going up and down, and the bottom chart looks like it might be like a complicated trade with pros and cons. But the secret there is that one, the robot does not care how much work it does because it's a robot. It will do as much work as you want it to. And two, the software consumers outnumber the software producers dramatically for any non-trivial, for any well-used framework. So if you can take on a bit more work centrally, if you can take on a bit more effort and complexity as a software producer to offset work for the software consumers, and then your software consumers are multiplied hundreds, thousands, tens of thousands of times, that is a great deal. And that's a deal you should take every time as someone who is producing tech for tech software. And that, I think, is the utopia that we can get to with tools like OpenRewrite. If we can instill that responsibility on people that produce software that is intended to be consumed as a library by other forms of software, and get those producers to take on more ownership of the migrations on behalf of their users, we reclaim a whole lot of capacity, right? We scale better, life is good. And that is pretty much the conclusion. So as a little summary, got some nice key images on the right here. For the folks that think that feel like they're in the leader bucket in this room, the recommendations here include knowing your risk tolerance for the applications that you care about and helping decide on the upgrade cadence. How careful do we need to be with staying on supported versions for the applications in our ecosystem? If you're a JPMorgan Chase, probably pretty careful. If you're a team lunch bidder, maybe you don't need to worry too much. For the software producers, again, get an inventory. If you want to make any intelligent insights and decisions about how you're managing this ecosystem, you need to be able to measure it. And then second, again, if I'm boiling things down far, mature from, ideally you already have migration guides for version upgrades, mature from having those guides to also having recipes alongside your guides. And the recipes become the forefront of how your users interact with your upgrades. And for software consumers, the recommendations here, one, engage in open source in places where you are seeing and understanding and deeply invested in software. If that software is open source, you do yourself and the world a great service by getting more involved in the open source community in service of that software. And more broadly, if we're talking about just hygiene, just keep on walking. Don't stand still. Don't try to do giant leaps. Stay apace, walk alongside the broader framework and the cohort of people using it. You'll have a better experience, less work, more consistency, less risk. Life's good. That's about all we got. Some related reading. One, if you, again, as mentioned earlier, if you weren't around for some of the other talks in this conference, well, in general, they're probably all good. But in particular, for the folks here, the Spring Boot talks from Josh Long and Deshaun Carter, recordings should be up or going up imminently. Those are real fun. Go listen to them. I mentioned post-quantum cryptography and where it might land in the JDK. InfoQ has a nice quick little article, easy to Google. They'll summarize like relevant Java enhancement proposals to understand more about where that's landing. The unit testing book I mentioned is by Vladimir Korkov. I think it's published by Manning. It is really, really good. Unit test, I feel like testing principles have come up in most of the sessions I've been to here, and it tends to have been a brief mention along the way saying this is really important, moving on. If you want to actually get better at writing unit tests and write unit tests that don't make you feel sad as you write them, this book is really, really insightful. I would highly recommend it. And then beyond that, thanks to Pexels, Wikimedia, they gave images. Excalidraw let me draw all these silly things. Thanks to open source software, just, you know, all of it. And thanks to the JPMC boot team, who several of them are in the room right now, and they have heard several of these jokes repeatedly at this point, and they still laugh sometimes, and I'm grateful for that. So that is about it. We can open to questions. I didn't go a whole bunch into things like really gritty recipe development, but we've done a lot of that. So if folks want to talk about that afterwards, if folks have got to catch a flight, again, go catch your flight. It's 3:38, public service announcement. But yeah, I'm good. There's a question right there.
Yeah, I mean, it may have been kind of implied. I just want to make sure I understand kind of how y'all handle, since you have your wrapper library, the JPMC thing, right? So that, I'm guessing, brings in Spring Boot as a dependency, right?
Yes. So from a Maven model perspective, the JPMC boot dependency management concept imports all of Spring Boot's dependency management. The JPMC boot project provides its own starter parent, similar to Spring Boot starter parent, that has not quite an inheritance model of Spring Boot starter parent, but a very similar parallel implementation. And yeah, many of the JPMC boot starters we provide with little features will themselves have transit dependencies on Spring Boot.
So do y'all then, are you typically running like the community OpenRewrite recipes to upgrade Spring within that, and then publishing your own recipe to upgrade the users of JPMC boot?
Yes. Yeah. So we our JPMC boot recipes are built on top of those open source community Spring Boot recipes, partially because, as I mentioned, we started in like 2022. We started real early. Our work, to a large extent, predates some of the commercial Spring Boot recipes, which do exist and can be useful. We don't happen to use them. We got started real early. But yes, we're built pretty much exclusively on the open source ecosystem, and we've had ongoing conversations about Modern's paid offerings, but that's not the focus of the topic today.
So most of your consumers of this are just using OpenRewrite, just the open source.
Yes. And we've stood up a little tooling to help make sure we're putting like the right recipes in our users' faces. But yeah, it's all built on top of the open source.
How often do you create the custom recipes?
Yep. So we tend to, so there are Spring Boot recipes for, say, 3.0, 3.1, 3.2, 3.4. We match that pattern. So we have a corresponding JPMC boot 2.6 recipe that calls a Spring Boot 2.6 recipe. So if Spring Boot is doing those minor versions every 6 months or so, a new recipe for that version is coming out roughly every 6 months or so as well. And we, every 6 months or so, are building our corresponding recipe to go with that new version. So when we're really like on top of our planning, we'll be able to launch, for example, Spring Boot 3.5 coming out within a month or so. We'll, in theory, be able to launch JPMC boot 3.5 along with the JPMC boot 3.5 recipe in roughly the same date. And that kind of experience happens every 6 months or so.
Now the recipes are not
Yes. Yeah. So that is a bit of complexity. So in recent months, more of the very latest Spring Boot recipe development is now occurring behind paywalls and not in open source. There is still open source room for these Spring Boot recipes. So again, folks on open source software, wherever you benefit from these things, there is ample room for you to simply go and contribute, help to deliver the open source versions of these Spring Boot 3.4 recipes. That said, you know, paid offerings can deliver lots of value too, and there are paid versions of these recipes. We don't use those paid things yet, but what we do have is support for the JPMC boot specific features and some like bare bones Spring Boot elements on top. But yeah, that is an active point of conversation. Like I've mentioned briefly that we have ongoing conversations with Learn about paid offerings. That's part of the discussion as well. Like there's benefit that could be reaped by bringing in some of those recipes as well.
So is it the central team who developed all the recipes? What about, there must be a customization that is being done by individual teams?
Yep. So we broadly, our OpenRewrite ecosystem, our team supports the practice of using OpenRewrite and has a little bit of the tooling that we put in front of users to make it easy. We also, because we support JPMC boot, we maintain the JPMC boot recipes. But I also mentioned, for example, we have a lot of Terraform recipes for how we deploy infrastructure. That is maintained by a wholly separate team that owns the Terraform blueprints, right? They own how we use Terraform, so they also own the recipes that help people upgrade as they use Terraform. Excuse me. We beyond that, we've got a pretty good, let's say maybe we've got roughly like a dozen or so different teams that do some form of recipe development and put that in front of JPMC's broader scale. I don't think we've reached too much of a point yet where arbitrary developers and arbitrary business units will go and just spin up recipes for their own purposes willy-nilly. I think there's a bit of a cost benefit graph where if you are focused on like a small business unit, even if you've got like a good 10, 20, 50 applications in your estate, the cost of writing a recipe at 10, 20, 50, at like 50 or so repos, yeah, writing a recipe might be a faster way to get your changes done. But if you are a business unit supporting like 5, 10 repositories, it might be faster just to make the change yourself, make it manually. There's a cost benefit curve for when it makes sense to write a recipe. I didn't include too much detail in here on that, but there is a sweet spot, and it's about finding the right one.
Can you speak to how you test recipes, like whether it's like something for your internal food or like just
Yep.
testing spring stuff?
Yep, so we've got a few patterns for that. One, the unit testing pattern that ships with OpenRewrite, I would say is pretty darn good. So if you haven't seen that before, it's largely declarative. So you say, here is an example of what I expect a Java file, a hypothetical Java file to look like before a recipe. Here's the recipe I want to run, and here's what I expect that file to look like afterwards. That model by itself gets it pretty darn far for cases that you can anticipate, right? If you can imagine different forms of syntax that you want to be able to refactor, that unit testing scaffold works very well. So we invest quite a bit in unit testing. We also have a bit of like a functional testing pattern that we use where we will maintain some set of just sample repositories that use some small number of Spring Boot features. And as we release new JPMC boot recipes, we will run those recipes on those projects, mostly to see what kinds of other cool new recipes are included in the open source side that we now need to be aware of and perhaps adjust our communication to our users about what you can expect from the recipe. So we did a little bit of like broader, not even quite regression testing, because sometimes it's a change that's a fun new change that we like to see, but just change detection through cases like that. And beyond that point, we don't have great mechanisms on our side quite yet for doing true bulk recipe execution and assessment of results. That's something that, for example, Modern's tooling can be really, really helpful for you. But for our cases, past that point, we are mostly reliant on our support relationships, where we have a real tight communication channel from our users to ourselves. And so if the recipe misbehaves, they often will just come tell us about it, and then we'll go try to fix it. And that kind of thing is hard early on when the recipes are very new, but I will say it's if you keep plugging away at it, it tends to get pretty good. We get not too many questions about recipe quality these days for the things we put out. I think the behind your team. So our team, I put on the slide like 10-ish. If I'm thinking specifically, there's like several of them are in the room. There's like 6 or 7 of us engineers. There's some product alignment. We got some close partners. So yeah, less than 10 of us doing all this and other stuff, Mhm.
How often are you on?
Yep. So I mentioned earlier that Spring Boot releases patch versions every month. We do the same thing. So we pull in Spring Boot's patch version. We do a similar kind of like vulnerability check for the other libraries that we introduce for our own purposes, which we try to keep to a small list, right? Wherever we can stick to the libraries that Spring uses, that's better. But we do have the same monthly patch version cadence where we fix any vulnerabilities we can see. We also, for our purposes, we also extend Spring Boot's open source release cadence a little bit, where, for example, the JPMC boot 3.2 version is going to stick around a little bit longer than the Spring Boot, again, open source support, the 3.2 version, just because that works well for our ecosystem. And in that case, we are pulling in Spring updates where available, right? Like a Spring Boot patch version or a Spring framework minor version might stick around and get patch versions longer than the Spring Boot. So we can just plug those things together, or we can just keep track of things like Tomcat. Like Tomcat has a vulnerability that is a couple versions back. Spring has stopped supporting this, but we still keep an eye out on that. So we'll just pull in the Tomcat upgrades. I think I got one question there, and then one other.
I was just gonna say, I think it daily scans, and we send ourselves email and stored versions.
Yeah. Yeah, so that's my boss over there. Yeah, so another cool thing we do, yeah, we like truly every version of JPMC boot that we have released down to the patch version. That's a large number. We rescan the entire bill of materials that comes with that version history against our scanning tools every single day, so that we are never surprised by one of our users telling us that they've had a vulnerability on XYZ version.
So what we did, and I did from our understand is we had our own custom archetype. There's an archetype that we used to, we define. And one of the things that we were thinking of doing in some of the other teams with this situation did was we created like a parent POM file or a parent, which where all the dependencies were stored.
Mhm.
And that was what was inherited by all the new projects. So did that approach ever appeal to you, or?
Yep. So there's a few ways you can look at that. One, you could argue that something like Spring Boot Starter Parent or our analog JPMC Boot Starter Parent is pretty much exactly that. It is a common parent that many projects can inherit from to get sensible dependency management. I think that pattern works best if you're very careful about how many users you expect to support. If you expect that this reusable parent will be used very, very widely and supported and maintained for a long period of time, you're in good shape. If you have on the other end of the spectrum, like hyper-local teams, like maybe like one Scrum team that supports 5 or 6 repositories, and they decide we're going to make our own local super parent like that. In my opinion, and in some of the docs, that's another thing. I don't know if I've mentioned this. The opinions in this stop are all mine. No, not reflective of JPMC. Should have said that earlier. In my experience, people very often will see an appeal of saying like, okay, we got like 5 repos. Let's do some shared dependency management for that. Let's create a 6th repo that is the parent and maintain our stuff there. 2 challenges with that. One, if you're just trying to like maintain more versions and like make fewer touches, well, now you have to touch 6 repos instead of 5 when you want to upgrade a version, because you still need to update your child repos to use the new parent. That's something. And also tooling like OpenRewrite and those recipes will get confused by a pattern like that. If the Spring Boot recipes are dependent on assuming that your project is either using Spring Boot Starter Parent or Spring Boot dependencies, they'll still do useful things if you aren't using that, but the recipes work best if you're in one of those scenarios. And if you have a bespoke local parent that indirectly pulls in Spring Boot, it is more difficult to make those upgrades programmatically. Because imagine what the recipe would have to do, right? If there is not, there might be a newer version of your local parent that contains a newer version of Spring Boot. Is the recipe going to find that? Maybe. If it doesn't exist, then the change needs to start with your parent library, right? That's a different repository. Spring recipes or recipes tend to operate one repository at a time. So you have a work needed on the parent repository side to get that change out. And then that change needs to actually be released into your artifact ecosystem so they can be pulled in back to the child repositories. There's sequencing there. So it's not something that should never be done. In our experience, we see a lot of users that inherit projects that use something like that, and that pattern is no longer helping them, it is hurting them more than it's helping them. It's about how long you can commit to maintaining that pattern and whether it's truly helping you out to make fewer changes to your projects.
The very good question was, what we found was that, it seems like Spring Boot is a large portion of your Java repository.
Yes.
Whereas in our case, Spring Boot is like about 20% of our, in Spring is about 30% of our, and then there's other frameworks, including custom framework we built on Vertex and other Java-ish, and other Java frameworks. So they all have the same need to use OpenRewrite for Java upgrade.
Yeah.
Not everybody was a Spring upgrade or a Spring Boot upgrade.
Yeah.
So is that any, I mean, it sounds like you have a very uniform landscape of mostly Spring Boot applications.
Yeah, within our Java ecosystem, I think, yeah, it's fair to say our Java ecosystem is mostly Spring Boot applications, and most of the Spring Boot applications are JPMC boot. If you're using other Java ecosystem frameworks besides Spring Boot, OpenRewrite is still going to work just good, right? OpenRewrite generically has extremely powerful coverage for the Java ecosystem. The difference is going to be you'll have all those building block recipes, rename a method, rename a class, use this method instead of that. You won't have many of the next layer up recipes of like, do Vertex upgrades, do the upgrade for the thing that you built that depends on Vertex, which means you've just got a little bit more of a lift that someone would need to take on. And that's comes back to just the power on being on popular things, right? If some of the newest, shiniest frameworks like Quarkus and Micronaut, things like that, I've seen investment in recipes from them, right? Like this OpenRewrite does have breadth in places besides the Spring Boot ecosystem, but if you've got things that are focused on, internal frameworks, or frameworks that are built out of older patterns, your mileage starts to get worse. There's still an opportunity. There's still full opportunity, but you won't be able to just pick up off the shelf Spring Boot recipes as easily. You'd have to do a little bit more work yourself to write them out, which could absolutely still be worth doing depending on your organization's numbers, right?
And are you deploying to the cloud in the same way? Because you're using Spring Boot, like you're using like Spring Cloud or some of those kind of libraries.
We've got a good mix of infrastructure systems. One thing I didn't mention here, I mentioned it very briefly. So in theory, Spring Boot and Spring Cloud are separate projects, related but separate. Spring Cloud depends on Spring Boot. One thing the JPMC boot does is it provides dependency management for both. So in theory, we help users keep aligned for those two version trails, because Spring Cloud's versioning can also just be a little bit surprising to look at. It doesn't look quite like Semver in a lot of cases. So we do have folks using the Spring Cloud ecosystem. We do have a lot of applications deployed to various cloud providers. I'd say we got about anything you can imagine within the Spring Boot ecosystem in terms of which features people are using and where they're deploying.
So the mix of on-prem and multi-cloud.
Yes. Yeah.
Do you use the recipes for batch versions as well, or only?
Yep. We release recipes at the granularity of minor version, which matches Spring Boot. So if you look at, for example, the source of Spring Boot recipes, the Spring Boot 3.4 recipe will say, change this version number to 3.4.x as a placeholder for just like find the latest patch version at the time. For a while, we maintained a strict point of control where we said, okay, we know that the latest version of JPMC boot is 3.4.4. We're going to code that in the recipe, and every month when we do our patch versions, we're going to update the recipes as well. We recently, past few months, moved away from that. We're also just doing the .x pattern now, mostly because we just reached that level of confidence in our recipes that like we usually don't have any weird side effects from new patch versions coming out every month. So we are comfortable just having our recipes pick up the new JPMC boot patch versions every single time they come out.
So are you saying that you're maintaining the versioning with the Spring Boot version or the recipe version?
So JPMC, I guess I didn't make this. JPMC boot aligns to Spring Boot in major and minor versions. Patch versions, not necessarily, because we might have bonus patch versions for whatever reason if something really relevant comes up, or we also are just supporting a minor version for longer than the corresponding Spring Boot release line. So our patch versions don't line up usually. If they do, it's kind of coincidence and they drift apart eventually, but our major and minor versions align by convention on our side.
And how you add your own features on top of your JPMC?
Yeah, so if I understand the question, so for an example, right, so Spring Boot 3.5.0 is coming out, what, in like a month or so, Matt, or tomorrow, or a couple of weeks? Okay, so Spring Boot 3.5.0 on the way to 3.5.0 has released milestones and release candidates. We, a few weeks later say, okay, with Spring Boot 3.5.0 release candidate now exists, release candidate 1 exists, so we are going to release JPMC Boot 3.5.0 milestone 1 based on that release candidate. So we're a little bit staggered for the launch of the new minor version. And when Spring Boot 3.5 comes out in about a month, our JPMC boot will probably come out maybe a month later. Depends on how fast we are. New features, in theory, we'll have already developed them, and we'll have already handled the new breaking changes in Spring Boot because we're tracking their milestones and release candidates. So there's a little bit of a delay. But past that point, once a given release line is active, once a given minor version is active, we're just, Spring Boot releases a patch version each month. And then a couple days later, we release our patch version on top of that to pull in their latest stuff and any other stuff we've added. All right, I think that's about the time. I'm going to stop the recording. I think it's 3:57. The closing's at 4 o'clock, right? Okay, closing's at 4 o'clock. I'm sticking around. I'm gonna go to closing. If the room clears out, if people have other questions they want to talk to me about, we can do that too. If you got a flight to get, just go get it. Other than that, thanks everyone.